Find the area trapped between y is equal to x plus 3, x minus 1, x minus 5, and y is negative 7x plus 7. So we can see negative 7x plus 7 is the red line, and this is the blue curve. So we're trying to find the area shaded here and here. We need the points of intersection. They look like they're at negative 2, 1, and at 4, but of course you can never go by just looks like. But I'm going to use the calculator in order to solve for these points of intersection, because actually solving this is a whole question in itself. So we're going to solve x plus 3, x minus 1, and x minus 5. We're going to put that equal to negative 7x add 7, and indeed exactly as it looked, negative 2, 1 and 4. So negative 2, 1 and at 4. Now note this function is on top between negative 2 and 1. So we could do this as the integral from negative 2 to 1 of x plus 3, x minus 1, x minus 5. Now I'll put the dx there too soon, because what we need to do is take away the negative 7x plus 7. So that's the difference function. So that'll work for this one and give us a positive answer, as we'll see in a moment, because the blue is above the red there. Now in this section the red is above the blue. So from 1 to 4 we'd have to do the negative 7x plus 7 take away the x plus 3, x minus 1, x minus 5. And as we'll see in a moment, that gives us a positive answer. So I'm going to do the integrals on the calculator. Obviously we could do these manually. So let's integrate from negative 2 to 1, and we have x plus 3, x minus 1, and x minus 5 take away negative 7x add 7, and just make sure we've got a dx on the end there, and indeed we get a positive answer, which we'd expect because we did blue take away red, and blue is above red. Now if we come to the next one, we're doing it the other way around, and we're going from 1 to 4 where the line is above the curve. So that's going to give us the negative 7x add 7 take away the other function, so x plus 3 and x minus 1 and x minus 5. And of course that needs to be dx as well. So that gives us 81 over 4. That's nice and symmetric. So the total area is obviously going to be 81 over 4. Add 81 over 4, which is 81 over 2. Now, can we do this with the modulus? Now, if we put a modulus around the whole of this function, it doesn't matter whether we use the first one or the second one actually, but remember we want to integrate all the way from -2 through to 4 this time, and that does give us 81/2. So we can use the modulus when we've got the calculator available, so we don't have to do it in two parts.